Right, let's look at 2015 AP Physics 1 free response questions. All right, number one, you have a connected system. Two blocks connected by a string of negligible mass, massless pulley. So you don't have to worry about the torque on the pulley question here. And negligible friction, and M2 is heavier than M1. Then we usually, as usual, we start with the free body diagrams. Let's go over what's happening first. Since M2 is heavy, this will go down that way. This will go this way. And small mass M1 will accelerate up. Here we have to agree acceleration of M1 equals acceleration of M2. Otherwise, this rope will be stretched out, right, if they have different acceleration. Or you can argue initial velocity will be 0 for both of them, and final velocity will be same for two masses, right? And for M1, it's easier if you choose winning side, it's moving up, or the net force is upward. So I'll choose this as positive direction, that's negative direction. For block 2, this is actually same direction for block 2, which is positive down, negative up. So choose winning side as positive, choose winning side as positive. For block 1, now this one you have to be careful with, you have to draw relative lengths of all vectors, meaning tension here has to be equal to tension there, because this is one rope and the pulley is massless. If pulley is not massless, then you can say tension on the right is bigger than tension on the left, otherwise this pulley cannot rotate. But in this problem, it's massless pulley, so simple case, you just use the same tension for the rope. So for M1, block 1, I'll make tension that way. For block 2, tension is actually applied up, but this length will be same, so I'll put this way. Now for block 2, downward gravity has to be bigger, so it has to be bigger than 3 lengths, like this is 1, 2, 3, so I'll make it 4 here. And for this one, I'll make it 2, okay? So the difference is their mg difference, right, of two masses, okay? Do I need to label? Okay, you need to label. So this is tension, this tension, this is M1g, force gravity for M1. This is force gravity for M2g, okay? Sometimes I'll use M as small mass, capital M as large mass. For this problem, they just use M1 and M2, okay? Now, drive the magnitude of acceleration of block 2. But remember, acceleration is same in terms of M1, M2, and G. There are two ways to do this. One is using individual mass. Second method is using as a system. So usually you'll start with the individual method, but once you get used to it, you can actually use it as a systems, as two block as a system. So I'll show you both way. So we'll use systems of two blocks, or this one we're just using M1, M2 separately, okay? So let's start with block 1. So block 1, I'm referring this guy. So block 1, it's moving up. So again, I'll choose tension as positive direction minus, so I'll just write F net for M1. So tension minus small M1G equals M1A. For F net M2, you have gravity winning. So M2G minus tension equals M2A. Okay. Now, if you, and you have to, again, we have to agree on this tension equals that tension because it's the same rope. And we have to agree on this acceleration equals that acceleration because they're connected system. Now, if you add them, you'll cancel tension. So on the left side, you have M2G minus M1G, okay? So it's M2G minus M1G equals if you add them, you get M1A plus M2A, and you'll factor, and remember you're looking for A, right? So if you factor G on the left side, you get G M2 minus M1 equals acceleration M1 plus M2A. So acceleration, I'll change the side. So this acceleration will be G M2 minus M1 over M1 plus M2, right? So that's how you find the acceleration. A lot of times they ask you what happens if M2 is massive or M1 is massive, what's going to happen, that type of question. So let's think about what happens here. And it's always good to check how to analyze the equation. So let me erase this for now. So in this case, if M1 equals M2, then this becomes 0. That's kind of obvious. Then acceleration is 0. Acceleration is 0 doesn't mean it's not moving. Acceleration is 0 means velocity is not changing. Okay, so but initially initial velocity was 0, then it's not going to move. But somehow I pushed it so the initial velocity was, say, 1 meter per second. Then in this case it'll just move with 1 meter per second without changing. Okay, so but this one tells you if M1 equals M2, your acceleration is 0, that means velocity does not change. If initial velocity was 0, final velocity is 0. If initial velocity was something else by means of other force, then you'll keep the velocity constant. Okay, now what happens if M2 is infinite? Let's think about that. If M2 is infinite, M2 is infinite means this guy gets massive. If you think about it, if this guy gets massive, it's not going to feel much of this small mass, or this tension will be actually small in this case, then compared to the gravity of that. So if M2 gets massive, this gets massive, then M1 doesn't mean anything. M1 doesn't mean anything again. So basically you'll get Gm2 over M2, which is basically acceleration will be close to G. Okay, so these are like common problems you'll encounter. Okay, this type. All right, now let's go back to this. Now if you put this together, and here you cancel T, that means if you think M1 and M2 as a system, this tension, the reason it gets canceled out is because tension is internal force. Okay, it's basically action and reaction, internal force. So if you think about as a system, this tension here, this tension there will actually cancel each other out. So you don't have to really worry about this. Okay, so the only external force is of the system is this force, which is gravity of M2G, the heavier mass, and this force, which is M1G. But so the net force on the system will be basically M2G minus M1G, which equals MA. But in this case, you have to use, because you think it as a system, you have to use total mass, M1 plus M2A. So basically F equals MA. Okay, and then you'll end up the same answer at the end. So acceleration will be, if you factor G out, you get M2 minus M1 over M1 plus M2, right? So that's another way to look at it if you think this as a system. Okay, all right, next question, part C. Indicate whether the magnitude of acceleration, okay, blah blah blah, you have M3 added on top and there's no friction. Indicate whether the magnitude of acceleration of M2 will be larger, smaller, or the same as the original two-block system. Explain how you arrived at your answer. Again, if you can approach 3 different mass, M1, M2, M3, you can find out acceleration for each one, then you realize it's getting smaller. Or you can do it as a system too. Once again, let's think about this. M1, you have M3, then you have M2. So what are the forces? You have M1, M1G, then you'll have tension here, you have tension there, you have tension there, and you have actually I have to write tension left. This is tension left, this is tension right, and this will be tension right. Okay, and you have to look at a couple things. First question, is this tension equals that tension? Well, if these two tensions equal, then M3 cannot accelerate. So I know tension right actually has to be bigger than tension left. That's, you know, usual question you'll be asked. And this TL and that TL is same. This is action reaction. This TR is same. That's action reaction. So if you add all of them, if you think this three mass as a system, external force is these two, okay? Because once again, TL will cancel, TL will cancel. So, and I know this guy wins over that. So you have F net as M1G minus M2G, this M2G, this guy, M2G minus M1G is your F net of the system, equals total mass times acceleration. And remember, they're all accelerating same. The total mass will be M1 plus M2 plus M3 acceleration. So basically, acceleration will be G M2 minus M1 over M1 plus M2 plus M3. So obviously, acceleration will be smaller because this equation is almost same as before. If you compare this, it's almost same, except just added M3 there, right? So you can say you have same external force, but your total mass gets bigger, so acceleration gets smaller. Okay, acceleration gets smaller. Now let's look at. Actually, let's go back to this. I want to note one more thing. Okay, so here we know acceleration of M2, hopefully, acceleration will get smaller because of this added mass. Then what happens to this tension? Okay. So compare this tension, I'll call it TR, to the original question. Original question was you have M2 here and you have M1 here. So I'll just call it T in this case. Because I know acceleration of this guy is smaller, but the net force here is M2G minus, I'll just go TR equals M2A. So that's the new acceleration of mass 2. Originally you have M2G minus tension T equals M2A. That was the original case, right? Original case. But I know because you added third mass, this acceleration gets smaller, right? Of the new acceleration. That means TR is actually bigger than T, okay? Because TR has to be bigger than T, that's why acceleration is reduced compared to the original case. So sometimes they'll be asked what happened to this tension comparing original case. So once again, because you added M3, the overall acceleration will be reduced. The reason overall acceleration is reduced is because in point of view of M2, because tension gets increased, because the force down is still M2G, this is not going to change. But since tension increased, your acceleration decreased. Okay, that's another way to think about it. So I want you to think about in terms of M1 too. Let's think about what happened to tension. So I'll just give you as a question, and probably I'll ask you next time I see you. Okay.